Okay, you got some alignment equipment here, and you're probably gonna see this stuff, the answer to your questions appear as we go through this. I'm gonna do a little zoom here with my camera. All right. Now then, okay, what do you see here? What we see here is we see, and these are, kudos to Ford Motor Company. This is some public domain stuff that I found that I will hit you guys with. And this right here, we're shooting with our alignment from here to here, from there to there, from there to there, from there to there. Everybody that's done anything with our alignment machine out there knows that if you stand in that beam and those cameras can't see each other, all of a sudden it goes wacky on the screen and it tells you it doesn't know nothing, right? You been there before? Okay, so what is this right here?
Steering wheel.
It's pretty smart. Yeah, you can't get no past him, can you? All right. Okay. Now then. Okay, here's the electronic. See, this one right here is the one that they've got pictured here is a Hunter alignment machine. I had one of these out there for a long time. This was a Hunter 411. Or I think that's what I'm talking about. Anyway, long and short of it, I had one of these, and eventually I had to replace it. And they got to the point where they wouldn't update it anymore, and it was just old and all that. So I replaced it with the machine that we got now, which is pretty cool. And so inclinometers measure camber, caster, and SAI. Now, what's SAI?
Steering axis inclination.
Can you draw steering axis inclination on your paper?
Yes.
Yeah.
Everybody do that. Draw steering axis inclination. Make sure I know where the ball's going, and all that. Inclinometers. Now, what's an inclinometer?
He's checking.
Is an inclinometer, do you think, maybe something that can measure angles?
Sure.
Away from true, north or whatever. Laser beams, reflective lights, string lines. Some of them the old ones used to have a string line that you hit from one head to the other. And all that.
Like partners.
Hello? Hey. Just send it to me. Just throw them at me. I'll be all right with those. All right, Danny boy. All right. Laser beams, reflective glass, string lines. Now, one of the things that she was asking me yesterday was asking me about this one question right here, where it talks about electronic alignment equipment provides for wheel alignment head runout compensation. Does anybody in here know what runout compensation is? Does you know what runout is? Somebody tell me what runout is.
Yes.
And then where one wheel is stuck out a little.
Not really. What you're going to have, what you have when you've got runout is if I've got a wheel that whenever it turns it wobbles like this, it's got lateral runout. And I'm talking about the wheel, not the tire. The wheel has got lateral runout. If you've got one that's doing this, when it turns, that's radial runout. See what I mean? And there's actually ways to measure all that. But the point is, when you hang these heads on a stamped steel wheel, now the aluminum wheels, the guy that sold me the machine says if it's a machined aluminum wheel on some of these newer cars, you don't have to worry about runout compensation because the wheel's perfect. Well, you don't know what they've hit. It may be bent, so you really still need to probably do it. On this machine over here, the way that you do runout compensation is you loosen up the heads where they can move freely after you get them hung. You guys have all hung the heads on this thing, right? Everybody hung the heads on it? The heads on the wheels. You hang the heads on the wheels, right? What you're supposed to do to get runout compensation figured up is it'll tell you to loosen the little locks and roll it back 45 degrees. So that the thing changes 45 degrees. And then you hit your OK, you level it. After you do that, you level it, hit OK. And then after you've done all of them, it's going to tell you to roll it back forward 45 degrees. And so you roll it back to where it was. And then you tighten them up. Well, you got to level it and hit OK again on each sensor. And then when you tighten them up, it has actually used its super digital ability to look at the cameras of these things when they were rolling and figure out how much runout they had. That's all it needs is 45 degrees. Now the other ones, like if you go to some of these tire stores, you will see them actually raise the wheel off the ground, and you'll put it at the 12 o'clock position, and then you'll push the button, you'll turn it either 120 or 180 degrees, depending on the machine. Push it again, turn it another 120 degrees, push it again, then turn it. And that way it has seen how much of this is there. So basically it compensates for the run out on the wheel. You got me? Now look at the answer to your first question and see what it is. The run out compensation. Now some of the ones that's got these big reflecting paddles, have you seen those machines that's got big reflecting paddles on their heads? No electronics in the head, just big reflecting paddles and cameras up there in the front. And what you do is you hang those paddles on there just like you're hanging these sensors, and then you roll the vehicle back and forward. And it actually has got little, segments on those paddles so they can read where those are, and it does run out compensation like that. All right. Regardless of the alignment system, alignment principles are going to be the same, no matter what you're doing. Now, the principles are going to be the same, but there's different stuff here. You got a computer monitor in a car. This is not rocket science. You've seen this. As a matter of fact, how many of you know that whenever you enter a car, you can actually go in there and you can put who owns the car, you can put the customer's name, you can put all that stuff in there. And then after you do your alignment, it knows when you started your alignment, it knows when you're through your alignment, you can tell it to print. And it will print a little matrix spreadsheet telling you what the alignment angles were before and what they were when you got done. So you can actually, if you want to, you can show that to your customer and say, this is where the angles were and this is where they are now. So it actually shows that you did something. And you remember when I was telling you about balancing tires, and I've told some of you this, if you balance, like I say, if you just take a tire off somebody's car that wanted them balanced and rotated, it doesn't really have a problem, you throw them on a machine, you spin them up, they're already in balance, why do I need to balance them again if they're already balanced? Well, a customer expects to see new weights on that tire, or they think you didn't do your job. So even if you do that, put another weight back in the same place that it was, you're not really remiss in your duties necessarily, but they're going to swear that you didn't do the work, but you charged them for it. And I'm going to tell you, in some of the shops, these guys that are doing balance and rotate will not balance and rotate the tires. They'll just claim they did it, and that's wrong. It's not ethically good to do that. If you're charging somebody to balance and rotate their tires, they need to get what they're paying for, and everybody knows that. But I mean, I've known of people ever since I've been in this business that tries that kind of hogwash, to get away, see if they can get away without doing all the work. Okay, computer calculates the measurements, stores the information. That is a 411 there. If you're going to be using it, got a Pentium processor with 8 megabytes of RAM. Whoa, that sounds like they're busting the walls out, right? This is old computer, yeah. The monitor displays the measurements and provides the adjustment target. All right, there's your electronic sensor. Uses infrared light beams and inclinometers, and we've seen how the sensor is going to provide inputs to the computer. And the little Hunter 411 that they're illustrating here uses 4 cordless optical sensors with self-censoring adapters. And you know what this is? One of the most annoying things that you can do when you go through an entire wheel alignment and you think you've got this thing on there like it's supposed to be, and you go into all the trouble to set the toe, you can get the toe set straight now, but when you're driving down the road, your steering wheel will be crooked. Customers don't like that. I mean, you can get the angles perfect, where they're just perfectly lined up, but if you don't have that steering wheel centered, you're dead meat. Incidentally, there was a Dodge pickup that we used to work on, a 91 four-wheel drive, that there was only one adjustment. So what you had to do was you had to adjust that thing where it lined up, and then you had to pull the steering wheel off and center it up and put it back on. That was on that one truck. That was what the procedure was at Dodge, But anyway, the steering wheel holder, everybody's seen that thing. We got one there that looks just like it. Keeps the steering wheel from moving when you're setting the front wheel toe. But this is the other thing. Let me tell you this so you don't get messed up on it. Whenever you're getting ready to set your toe, make sure that it's not bound up. You know what I mean? Because you can turn the steering wheel where it's straight, but everything will be kind of bound up a little bit. So you need to kind of jiggle it back and forth so you can make sure it's kind of where it wants to be. Because people will, I think they have it, the steering wheel holder will be on there, and they'll say, well, I know I put that thing on there. I know I had the steering wheel on there. Now when I'm driving, the steering wheel's crooked because everything's kind of bound up. Something else is annoying if you're not used to doing the front end alignment thing, is when you adjust this one, it will throw the one that you just adjusted off. Have you ever seen that happen before? That's kind of irritating. You got to go back and forth till you get them right. It's not bad when you got a live adjustment. How many of you know that you can use a tape measure to set toe and a carpenter's level to set camber if you
that one from Sean.
got kind of patience on it? Yeah, Sean's good jury rigger. All right. Okay, got a keyboard here. Whoopee, this is a really interesting picture. We got a keyboard there and a printer, and that machine there is no different. Notice how this is an old machine and that one over is sort of patterned the same way, you know? The printer's got the technician specs for diagnostic information. You got a wireless remote control. Now, that was something this one doesn't have. I had a remote control that was wireless in the 100 machine that I had. It looked like a big old fat TV remote. And you could actually move to the next setting from wherever you happen to be standing at. It also had a remote display. You could drag this display out, and they had a little LED representation of the alignment angles, and you could set it right there on the counter, and it would. Back here. I'll get a message in a minute. I'm tired of phone calls. All right. Vehicle rack. Now, everybody understands this turn plate right here, right? The turn plates on this machine are very expensive, or on that lift over there. And if you get too rough with those turn plates, you know, you're subject to cost me $500. So be really careful about that. That's why I said you always roll this, and you stop it. When you drive the car on, you stop it right there. When you're getting the car off the lift, particularly if it's a front wheel drive, you're going to let it roll back. You're going to roll it back off of here. Because the front wheel drive, when you go to take off, is going to try to dig out, right? And if these right here, a lot of times people won't even put those pins back in there, and it'll go clang, it'll slam that thing forward, you know. And if you have to shuck out $500 to pay for another turn plate, you know, I mean, I'm not saying anybody in here is going to have to do that, because, you know, part of the doing business thing. I had to put a guy, let me stop for a second. I put a guy that, well, actually, he went down there and hired on. He was a goofy student, and they had a tendency to make mistakes that I was really scared to place anywhere. And he just went and applied at the front end shop in town over here. And he did pretty good. He could do alignments, and he was getting everything. Well, one day they handed him a '68 Camaro that had floppy, loose pedals, and gear shifter wasn't right. And you know how old cars get to where you really don't know what gear you're in, and you know, clutch. He manages, believe it or not, to drive the thing off the front end lift into the front end machine. Like that. And so, believe it or not, the guy that he was working with didn't fire him. But when I found out about it, I said, why don't we move you to somewhere else before you kill somebody, you know? And so we got him a different job. He was a goofball. I don't understand what kind of a disconnect he had, but he was somebody that he would take a snap ring off, pull a part off, and then he instantly would pick the other part, put it back on, and forget the snap ring. You know what I'm saying? I mean, just strange the way you do it. Well, anyway, one way or another, he was reasonably intelligent other than that. I just never could understand what, you know, how his synapses weren't firing right sometimes. Well, I moved him to another place. The guy that owned the shop hired another guy that was an experienced front end man, and he says, you know, I need somebody that's got more experience than the kid I hired before. The second or third day that guy was there, he drove a car off into the new front end machine. I don't know what the deal was on that, or why it happened, or how it happened, but I mean, two guys within a week, that guy must have felt like he was in the wrong business or something. That was terrible, you know. I just couldn't imagine, you know, I could kind of imagine this guy that was over there doing it, but not another man, you know, that had more experience. Passenger light car turning angle gauges allow the wheels to pivot when you're taking measurement. What you need to do is you need the wheels to be able to move just real freely when you're making your adjustments. They don't need to be bound up and the rubber dragging on the metal and all that, because it's just going to be real difficult if you don't. Okay, believe it or not, this is the last slide. And since it's 30 minutes to lunch, we'll have to work another 30 minutes before we go to lunch, right? Okay, in order to achieve a proper wheel alignment, all the equipment's got to be calibrated and leveled. Wouldn't be a bad idea to be able to take a level over there, set that thing on its blocks, make sure it's level. Because if it ain't level, you're not going to get a good alignment, are you? Okay, once again, what's the first thing you do when you get ready to do a alignment? What's the first thing you check on the car?
Tire pressure.
Tire pressure. What else you going to check? I'm going to look under there. You know, anybody got to know what a dry park check is? You ever heard of that? Dry park check. If you just have somebody lay on the ground with a creeper, or lay in the grass, I don't care, and while your buddy gets in there and he operates the steering wheel throughout its free play. And you're going to see where that free play is, or if anything is loose moving around under there. You got me? Or if anything's flopping around. If you got stuff that's loose under there, or you're looking and you see things that are bent, that needs to be fixed before you can do an alignment. There's no point in doing an alignment if you got a bunch of bent front end part, or bent rear end part. You know, if the rear end is crooked under the car, you know, you got these trailing arms and all, if they're all bent and messed up, if you can hang the machine on there and try to make adjustments, but it's not going to be right unless you fix what's wrong. But anyway, that's about the end of that. Except for this. on air suspension, make sure you turn off the air suspension. In the black Crown Victoria that we have, the air suspension switch is in the left side of the engine of the trunk, and you turn off that. What happens if you don't turn off the air suspension when you raise the car up?
Bust the bags.
Huh?
Bust the bags.
Nope, they won't bust the
They
bags. Why would they bust the bags? What does it do?
They'll keep changing the
What are we
cap.
talking about?
Whenever you raise it one up, it's got rear air suspension on it. If you don't turn off the air suspension, what happens?
It sits down really low when you let it down.
Yeah, what it does is, it's got a ride height sensor, and this is part of the suspension, right? And whenever you raise it up, what does the axle do? It goes down. And the computer that's operating that says, my goodness, we're setting way up too high. I've got to let all the air out of the airbags. So it lets all the air out of the dadgum airbags, and when you set it down, it squats down like a lowrider, and you can't even get the left arms out from under it. Until you start the car, and it's embarrassing when you do that at a shop. Ain't that right?
Right, Sergeant.
Have you done it?
No.
Okay. Make sure you don't get embarrassed like that. You let it down, and the other mechanics are like, but I mean, you aren't hurting anything, but you're sitting here and it goes, and then it'll pick back up. You hear that pump running. If, however, for some reason the pump won't run, then you got some issues. I mean,
Dead
but
battery.
of course, if the pump won't run, you're probably going to have flat airbags anyway. Now, yeah, I mean, like the batteries did, it won't run. But anyway, you're going to have to be able to get that like that. Make sure you remember to turn that off. It's only the black one that we inspect every month is the only one that has that. All the rest of the Crown Vics don't have it. Lincolns will typically always have it. On an Expedition, like the one that he's working on over right now, I don't know if it's got air suspension on it or not, but the air suspension switch on that Expedition is in front of the passenger's right foot under there. You look under the dash, it'll be right there. Click. On these cars, it's in the trunk. Okay, so just remember that. The electronic, portion of our steering and suspension curriculum will cover that. Okay, anybody got any questions?